evening, everyone. On behalf of TEF 2025 team, I'd like to warmly welcome all TEFians to the 11th session of our exciting TEF Tech Talk podcast. TEF podcast is dedicated to delivering inside technical sessions that are valued to our engineers across various fields and acquire the technical knowledges. Today, we will be discussing the fascinating topic of advancement in maintenance of rotating machines and insights into oil and gas rotating equipments. I am G.Raja, Lead Engineer, Rotating Equipment Sales, working with KUF General Trading and Contracting Company. Today, I am pleased to welcome our guest speaker, Engineer Raja, Senior Engineer, Rotating Equipments, working at KNPC MAA Refinery. Engineer Raja brings extensive experience in the maintenance of rotating equipments, particularly within oil and gas industry. Welcome, sir.
Hi, Magraj. How are you?
Good, sir. Yes.
Yeah, welcome
Thanks.
to the show. And thank you very much for hosting this podcast. Let me see that how we can going to deliver whatever we have in mind to the audience.
So, now coming to the title, sir. Advancement in maintenance of rotary machines. We would like to know, in India, normally, there will be one maintenance technician who will be taking care of all mechanical items, a common team in charge for whole plant. But in GCC, oil and gas segment, there are separate divisions within the mechanical equipments, like static, planning, rotating equipments are there. Why this difference and what is the importance, sir?
Yes, Magraj, you are correct. The scenario in India is different and the GCC countries are different. Especially in the oil and gas sector, the scenario is quite different due to so many factors. Before getting into this factor, I will just explain about a scenario. Can I tell you that when the refinery is started means what could be the initial operation or initial startup of the refinery, what type of equipments is started? It is nothing but rotating machineries only. Maybe it is a starting of a pump or starting of a compressor or starting of a turbine. Then it will initiate the startup of the refinery. Obviously, the shutdown is also the same. If someone is telling that the refinery is shut down, either the planned shutdown or unplanned shutdown, definitely it will be an initiation of stoppage of a rotating equipment. Maybe it could be a pump or compressor, maybe it is a planned stoppage or it is a breakdown. So this will indicate you how the rotating machineries are important for the oil and gas sector. So because of that, the rotating equipment in this region, such as pumps, compressors, turbines, and are highly specialized and they are massive and complex in nature and they are operating under extremely stringent reliability and safety requirements and are essential for continuous operation also. Failures in these machines can lead to a significant losses and safety concerns. And because of that, a separate division concept allows for a more focused, expert-driven approach since the subject matter specialist can develop in-depth knowledge and keep up with the technological advancement and respond more effectively to failures or maintenance need. Due to this, the specialized division model in GCC is emerged more and is indeed required also.
Thank you, sir. Sir, before going into the maintenance, can you list out some of the rotating machines used in the oil and gas industry and its specialization?
Mehraj, before going to industry, even our day-to-day life, we are surrounded with rotating machineries only. So without a pump, our morning will not wake up smoothly. That's why the rotating machineries are more important for our day-to-day life and also for the industry. When industry is concerned, these equipments are massive, complex, as I told, and it is having a safety requirements. Some of the most common rotating machineries, I can tell you that the centrifugal pumps, reciprocating pumps, these pumps, they are continuously transmitting the fluids to the process units and they are massive in sizes and they are very complex in nature. And also we have the reciprocating compressors which can feed the process gas to high pressure to the process units. And a vital equipment in refinery is the centrifugal compressors where this will be delivering the steady flow rate of gas to the process units. Apart from that, they have a steam turbines. Steam turbines, the bigger steam turbines are special purpose steam turbines and the smaller one are general purpose steam turbines. These steam turbines are used to drive the pumps and compressors as a prime mover. And we have gas turbines and gearboxes of varying sizes to step up and step down the speeds to have the torque value as per the requirement. And we have fans, blow airs and electrical motors. So each type of rotating equipment is selected and engineered to meet the specific operational, safety and efficiency requirements of its intended application.
Yes, sir. Thank you, sir. Well explained. Sir, you are in the field of past 25 plus years in the rotating maintenance. Can you explain how rotating machinery evolved in the recent years?
Yes, Maharaj, evaluation is everywhere and definitely here is also happening. But people may think that what evaluation will happen in machinery like IT, but there is evaluation and I can pinpoint some of the things. Even 25 years of experience, I have seen the construction of the rotating machinery itself, it was transformed in a variety of types. For example, the centrifugal compressors in olden days, it used to come with the wet gas seals. Now there is no wet seals for the centrifugal compressors. The wet seal era is completed. Now all the centrifugal compressors are coming with the dry gas seals. And moreover, nowadays there is no pumps with gland packing is being procured for the refineries and the petrochemicals. All the pumps are equipped with mechanical seals. That too for the API applications, it will be the API 682 mechanical seals. And you know that olden days, the turbines are coming with the mechanical governors. The one which we were studying during the engineering, that there will be two weights and based on the centrifugal force, when the weight goes high, the valve will open and weight comes down, the valve will close. That are all finished now. You cannot see. You can see such things in the exhibition or in the museum only. Nowadays, those things are replaced with hydraulic governors, and nowadays these hydraulic governors are again replaced into a electronic governing system. This electronic governing system, it is a very simple system and it is taking the speed sensors, and based on the speed sensor with the state-of-art control system, the turbine speeds are controlled in a very efficient and precision way. Even the overspeed trip system for the turbines, it is all changed from mechanical to electronic system. So because of this, the electronic overspeed trip system enables a higher level of safety for the turbines. And nowadays for the reciprocating compressors, there is no metal valves like steel valves. There is all non-metallic valves. Peak materials are being used. And the heavy-duty steam turbines are also being replaced with the gas turbines because of its economics. And the anti-surge systems are become state-of-art anti-surge system for the centrifugal compressors. We have a better control and better efficiency. And there are sealless pumps and integrally geared compressors. These integrally geared compressors are operating at 50,000 RPM, and these compressors are energy efficient and very compact in sizes, and many aerodynamic designs are coming up, and advanced high efficiency machines are being coming, and many advances is taking place. For example, we have nowadays the state-of-art vibration sensor and other machine monitoring sensor installed in the machineries, and these sensors are connected to the control systems, and because of this advanced control system integration, the industry witnessed a shift towards digitalization, automation, and smarter and more efficient designs. So I think you can understand that how even the machinery also, how in the recent days it is evolved.
Yes, sir. I can understand. I think now everything is monitored in the remote, and then we can sense the readings through the online. So that is also available in the market. So could you please elaborate more about how the industry is working? I mean,
I think you are mentioning about the remote monitoring and the diagnostic system. Yeah. See, the remote monitoring and the diagnostic system is a state-of-art system, but it is having a wide application in the critical machineries. I will take you a live example and I will explain you how this remote monitoring diagnostic system is working. See, we will take a gas turbine as a typical example. See, the gas turbine is a critical machine, and also it is having a very complicated control system, embedded control system. This control system, it is specially designed by the OEM, and this control system is complicated, and it is getting updated every time based, it is getting updated. So whenever there is a issue arising in the gas turbine at the site, it is very difficult for the site people to attend this issue, because this is not the normal control system where in refinery other equipments are there. When the refinery, the instrumentation people are well versed with this system. But for such cases, whenever any fault arises, what they will do, they will be communicating with the OEM, and the OEM has to assist them to get this troubleshooting done. So because of that, this will have an implication in the increased downtime of the equipment. So for that, some of the manufacturers, like gas turbine manufacturers, they are just just making a facility that the OEM will be employing some people who will be sitting there and they will be monitoring the real-time data 24 into 7. So whenever any abnormality is happening, during that abnormality period, they will be immediately informing the site group about the abnormalities and they will be advising them to check what is happened, and also they will advise them if any trouble is happening, they will also advise how to troubleshoot the issues. So because of this remote monitoring and diagnostics, it will enables troubleshooting in a very shorter period, and it saves a lot of money to the organization. That's how the remote monitoring is working. And the remote monitoring concerned, it will be having expert engineers and maintenance teams, and they will be sitting at the facility. And this is more economical for the organization also. How it is economical? Because if I have only one gas turbine in my system, if I want to employ a remote monitoring diagnostic specialist engineer for my site, and if we want him to be sit in our site and to monitor 24 hours, then I have to employ 3 people, and all these things will be there. But however, if it is there in the remote monitoring center, this remote monitoring center is having a wide number of machines, and they will be employing limited group of people, so that they will be sitting there and monitoring a wide range of machines, so that it will be economical for us also. That's how the remote monitoring diagnostic system is working, Nagaraj.
Yes, sir. You are giving a clear idea of what is the rotating machineries. Now we will step into the maintenance, sir. What are the maintenance strategies involved in the recent days for rotating machines? Could you tell us more about it?
Yeah, modern maintenance strategies for rotating machine has evolved significantly with the advancement in this digitalization, analytics and sensor technology, Nagaraj. Today, the maintenance approaches are typically categorized into 4 types. One is the reactive maintenance, and another one is this preventive maintenance, and the predictive maintenance, and the prospective maintenance. See, speaking on reactive maintenance is nothing but the run to fail maintenance, or it is a breakdown maintenance. See, people will think that why this maintenance is not a correct method, because it is allowing to run to fail. But obviously, there are some items which we need to maintain, which we can allow them to run to fail. Because see, the economics in the maintenance involved that what cost we are spending for the materials, and apart from that, we have to compare this cost spent on the materials to when this equipment is not available, what could be the losses. We have to integrate with the maintenance cost as well as with the losses incurred when this equipment is out of service. So such cases, whenever we have a machinery which is non-critical, for example, you can say that there are 2 pumps, and one pump is running and one pump is standby, and one pump runs and the standby pump can start in case of any problem of the running pump, and there is no any disturbance in the process. Obviously, this has become a non-critical item, and there is no need for doing any preventive maintenance to these pumps except the lube oil management. For example, the mechanical seals or the bearings, they are all allowed to run till it fails. There is no any preventive maintenance for the mechanical seals or the bearings other than the lube oil management. That's why reactive maintenance is also to be practiced, is accepted for some of the maintenance category. And secondly, when we come to the preventive maintenance, this preventive maintenance, everyone will think that the preventive maintenance has to be done for all the equipments, and it is nowadays it is not a correct concept, because the preventive maintenance, considering the rotating equipment point of view, the preventive maintenance nowadays is having a less importance. I will tell you the reasons in the later sessions. Preventive maintenance is not like it's a good method which is being practiced for the rotating machineries because of the emerging of the predictive maintenance. So the preventive maintenance is having only limited period and limited activities on the rotating machineries. Like we will be doing the preventive maintenance only for the coolers, lube oil coolers and lube oil tanks and all these things when there is a turnaround is happening. We are not just stopping the rotating machineries after 3 years or 4 years and remove the machineries and complete overhauling. We are not doing that, and it is not required also. And coming back to the main important, this predictive maintenance, this is the wide maintenance method being followed for the rotating equipment machineries. The predictive maintenance is nothing but the word itself is telling that we will be predicting the equipment before it fails. So we should have an arrangement and we should monitor the equipment continuously and we should predict the equipment will fail after some time. When we have a prediction method, then based on that, we will plan for a stoppage of this equipment and we can caution the operation so that they will do some alternate arrangements so that they will hand over the equipment to us. Because of that, the predictive maintenance always it will have a very good result so that the machine will not be stopped unnecessarily and there will not be extended failure days and operation losses all are minimized during the predictive maintenance. Then finally about the prospective maintenance, this is nothing but the most advanced strategy where this we will be combining the predictive maintenance. The predictive maintenance will inform us that when the equipment is about to fail, and the prospective maintenance one step moving forward. This type of maintenance we will be having a remedial action also. The predictive maintenance, with the predictive maintenance techniques, we will find out what is the fault. But however, this prospective maintenance or reactive maintenance, it will give us an idea what is to be done to avoid this failure and how effectively we can repair it. So now the growing trend is the integration of these 4 strategies into a comprehensive asset management programs. The results in improvement reliability, enhanced safety, and greater cost efficiency throughout the equipment cycle. Nagaraj.
Yes, sir. This is very clear to us, sir. Sir, when you say about the preventive maintenance is less importance nowadays, and it's only for having a limited activities, is the same applicable for all the machineries in the industries, or are there any exemptions in that?
See, preventive maintenance, if it is considered like 80% of the machineries are not maintained, we have not have a full-fledged preventive maintenance for the equipments. But however, there are some machineries which we need to have the preventive maintenance. For the example, I will give you the gas turbine. This gas turbine is operating at very high elevated temperatures, and the gas turbine has certain parts which is exposed to high temperatures. So these parts we cannot run it till it fails, or we cannot predict when it is going to fail. So for that items, the manufacturer will be recommending some firing hours. So after some certain firing hours, we have to replace those parts. For example, in gas turbine, we have to do the combustion parts replacement every 12,000 hours. And every hot gas parts has to be replaced every 24,000 firing hours. And definitely the gas turbine has to be overhauled in 48,000 hours running hours. So for such equipments, there is no any other way. The preventive maintenance has to be done. For some items only the preventive maintenance is followed strictly, and other equipments the preventive maintenance other than the lube oil management. Even the lube oil management nowadays comes under the predictive maintenance, because nowadays they are installing a online lube oil analysis for the lube oil system. So this lube oil analysis system, it will gives the quality of the lube oil and it will indicate that whether the lube oil is deteriorating or when it has to be replaced, or any mixture is happening in this lube oil, any moisture content is happening in the lube oil. So all these things will be analyzed online. So the preventive maintenance is, as I told before, it is have a limited application for these rotating machineries, other than some specific machines which they have very unique in nature.
Yeah, that is very clear, sir. Thank you. You are speaking a lot about the predictive maintenance rather than the other maintenance. Could you explain more about its basis actually?
Yeah, we can do that, Megharaj. Predictive maintenance is an advanced maintenance strategy aimed at anticipating the equipment failures before they occur, as I told before, allowing for timely interventions that minimizes unplanned downtime and repair cost. This is mainly achieved by data collection and analysis. For example, in predictive maintenance, 24/7 real-time data collection is enabled by the vibration sensors and the online monitoring system. And also, this data collection will be carried out for other parameters like the oil temperature and the oil quality, etc. Then, this vibration data, whatever it is collecting, this is compared to the predefined baseline values. For example, if equipment is running and it is running with 2 mm per second or 25 microns vibration, if a unit is running, this is a standard baseline value. So the data are being collected on real-time basis 24 into 7. So whenever these values are within these 25 microns, there will be no any issues. When this data starts up and down, and there is a fluctuation in the data, or there is an gradual increasing trend on the data, and there is an instant high value on the data, then it will be analyzed. Then it will cause for the analysis. So whenever the values are detected in an increasing trend or abnormalities observed, then analysis has to be performed. How vibration analysis is done is another important and interesting phenomena. You know that the rotating machineries, each machine or each parts, it will vibrate in a specific pattern based on the specific problem. So if a machine vibrates for unbalance, the pattern will be different. And if a machine vibrates for misalignment, or if a machine vibrates for a process related band pass frequency, this is different. So such things is the basic on this condition, on this predictive maintenance method. So what is happening? This fast Fourier transform analysis breaks down the vibration signals into the frequency components. When we are collecting the signal from the vibration sensors, this FFT analysis breaks down the vibration values into its frequency components. So frequency is always measured in hertz. You know that there is a frequency. Yes. The frequency is nothing but
1x, 2x.
Yeah. So the frequency is nothing but how many vibration cycle is happening per second. When we are analyzing the frequencies present in the vibration signal, it will help to pinpoint the specific faults. In addition to this vibration analysis done on the frequency, we will have an analysis on the amplitude also. Normally, the amplitude is measured in the millimeter per second. The strength or magnitude of the vibration indicates the severity of the potential problems. If there is a vibration is there, what type of vibration is happening will be analyzed by the frequency, and the amplitude will give the severity of the problems. And we have to analyze on the phase difference values also. This phase difference describes the timing relationship between vibration signals at different points, useful for diagnosing misalignment or resonance condition. See, the machine failures based on the type of machine, the failures are all classified. There are the predefined failures is available. For each predefined failures, the pattern for vibration or the spectrum analysis, it is having a specific patterns. So the experts will analyze the data, and whenever the values are going above the predefined values, then they will come into the picture and they will analyze on the higher values, and they will able to know that what could be the reason for this elevated vibration. And by studying the vibration patterns, these experts identify underlying causes of the abnormal vibration, so that accordingly they will indicate as, they will give us a report that what is happened. Maybe it is a wear, or it is maybe a misalignment, or it is maybe a loose components, or a process instability. Also, by tracking the vibration analysis, by tracking the vibration values, we can detect the gradual changes, and because of these gradual changes, it will give an implication on the wear happening on the machine. If there is a wear is happening on the machine, for example, there is a bearing failure is going to happen after 1 month, then the vibration values will start slowly increase. And if there is any deposition in the impeller or deposition in the rotor, then the unbalance will start. The vibration value will start slowly, and it will give an indication that there is something unbalance is happening. For example, if your blade rotor is suddenly broken, then immediately there will be increase in the vibration value. When the vibration value was increased, for that value, the spectral analysis is done, then we could easily know that there is an unbalance there. So based on that, the maintenance action is planned and carried out only when the analysis indicates that there is a risk of failure is increasing, preventing the unexpected breakdown. This is how the predictive maintenance is having much importance in the rotating equipment field, Megaraj, because it is avoiding unnecessary repairs and unnecessary maintenance and unnecessary losses.
Thank you very much for the detailed explanation, sir. With that, can we go further deep into the subject of advancement in the maintenance of rotating equipment and the insights of rotating maintenance for the oil and gas industries?
See, with this fundamental understanding of vibration analysis and predictive monitoring, we can naturally progress to the subject of advancement in the maintenance of rotating equipment. You know, the basic is this. we have installed a vibration sensor on the machines, and we have temperature RTDs on the bearings, and we have oil analysis. With all these things collectively, we can move on into the next step. We can move on into the advancement. What is available in the recent days. So in the recent year, the field has undergone a remarkable transformation driven by innovation in the sensor technology, data analytics, and digital connectivity. Today's maintenance strategies are no longer solely reactive. No one is waiting for reactive to happening, but they are not there to wait for the failures to occur. Instead, they are increasingly embrace the predictive and the proactive approaches. High fidelity vibration sensor combined with the wireless data transmission and cloud basis analysis now allow for the real-time monitoring of the equipment across the vast industrial status. This AI powered predictive maintenance is actually what, in simple words, I can tell you that we have patterns. We have patterns, the failure patterns, we have the failure models, and we have the vibration spectrum. All these things we have predetermined values. What is happening when the real-time values are taken? These real-time values are compared with that standard patterns, and based on that, this artificial intelligence will be informing us that the machine failure in advance, well in advance. So what this artificial intelligence is nothing but whenever this, as I told before, when the predictive maintenance happening, the analyst will come into the picture to analyze the problems. But however, in the artificial intelligence, there is no analyst is required, and this analysis is done by the artificial intelligence, and the remedial action or corrective actions will be given at the end. So this artificial intelligence is replacing the analyst in simple words. Second thing is we have the digital twins and the edge computing. So the digital twins and edge computing, in a simple words, I am telling that the digital twin is nothing but whenever there is a machinery, they will be developing a model of the machinery, that is the virtual modeling of a virtual machinery, and they will allow virtual machinery to run. So whenever any problem is arising, when they are collecting the data from the real machines, they will be stimulating these values to the virtual machines. So based on stimulating to the virtual machines, we will know that what impact will be happening to these machines and how long this machine will be withstanding with these higher values, so that it will give us an impact, exact impact that we can have cushioning of some days, and it will be happening only in some part of the machine. And all these things with this digital twin, it will give us an indicating. And there is a edge computing technology is there. The edge computing technology is nothing but because, for example, in remote or into the control rooms, the signal is transformed from to the remote stations or the control rooms. We may incur some losses, or maybe we can incur some losses, or the accuracy may be different. In that cases, the machine itself, a cutting edge computing system is incorporated in the machine itself, and along with this cutting edge system and the edge digital twins, the anticipating the failure with the machines will be evaluated very accurately and precisely. And nowadays, apart from these things, we have advanced repair and refurbishment techniques. Nowadays, the technology is having the 5-axis milling machines and electrical discharge machines. This enables to repair a very complicated parts also. And also, with this one, we can have a reverse engineering, which also brings the legacy components with the improved materials. Finally, the integrated sensor networks. Now, the modern rotary equipment is now embedded with the multi-sensor arrays that track everything from sharp vibration to lubrication quality. These sensors feed it into the centralized platforms for holistic asset health monitoring system, Raj. So these are all some of the recent advancement. Maybe something like the digital twin and the AI-powered AI-powered predictive maintenance and all. Maybe it is new to the people, but definitely this will become a part of the equipment monitoring when we will be buying the new equipments nowadays. So these are all the advancement what I just like to share with the audience.
This is very interesting, sir. Thanks for the deepest insight. Generally, the mechanical maintenance means we always under the impressions it is like a person coming with a coverall and then handy with some tools for the maintenance. But during our discussion, I'm just learning so many things, which is very advanced stage like AI, CBM. These are all like not only for the networking, it's also applicable for the mechanical maintenance. It is very interesting to hear. Thank you for sharing this information, sir. Also, I have one more question. Actually, as per API, for example, API 610 for centrifugal pumps, it calls for 25 years design life, which means the OEM has to guarantee the spare parts availability for the 25 years, which is the guaranteed factor. But nowadays, we are seeing so much of plants are running more than 40 years, more than 30 years, more than 50 years also, although. So how we are planning for the obsolete management studies actually for maintaining your spare parts for your mechanical maintenance?
See, Maharaj, obsolete spare part maintenance is a big problem nowadays. It is not only happening for even 25 years old machine, even it is happening for the 5 years old machine also. One of the problems we are facing in the rotating machineries, because you know that these rotating machineries are customized equipment. It is not like a pipe or valve or flange or heat exchangers like that. It can be manufactured everywhere. These rotating machineries components has to be supplied only by the OEMs. We cannot source it from others. If we want to source it from others, we should be making a duplicate product only. Because we will be having a product, we can make a replica of this one. But making a replica to this product is also highly risk, because we don't know about what type of heat treatments, what type of hardness, all these things, what they are doing it, the manufacturer, because normally manufacturers, they will not share such details. Okay. So normally we will be having a thumb rule that we will never go to the non-OEM spare parts. If a pump is concerned or a compressor is concerned, it is advisable, if you want to replace any spare parts, you have to go with the OEM. Because if the part by visually, it can be look like a same or similar, but there are certain things like the heat treatment, hardness, and the material grade. All these things will be different. So as far as rotating equipment is concerned, always we have to be rely on the OEM. So if OEM declares that if his item is obsolete, there is no any other way to look into the alternate options. If the OEM is giving some alternate option, we have to accept it, or otherwise we have to go and replace the entire machine.
Entire machine, yes. Understood, sir. It is yes, sir. It is very clear. Finally, before wrapping up our sessions, what is your message to young emerging rotating equipment engineers in the oil and gas industries as well as the other industries?
I cannot tell that I'm not a big person to give a message to the engineers, but I can share my experience as an engineer that maybe it will help to some people. See, for me is concerned, a rotating equipment engineer should be a 50% mechanical, and another 15% he should have a good knowledge on process, plant operation and instrumentation. Because why I am telling you this is, a statistic is telling that 80% of the machinery failures is happening because of process related problems. That is a third party problems. So if there is a problem, and if you are raising a flag on third party, then you should have a proper knowledge on third party's subject. So that's why I will always tell that a rotating equipment engineer will be fulfilled if he is having a good knowledge on plant operation, process and instrumentation. Secondly, people should understand that this maintenance expense for the organization is not only the cost, what we are spending it for the manpower or for the spare parts. It is like an iceberg. For example, you should analyze that if you are taking a rotating equipment for a maintenance, you should not think about the cost for the spare part cost and the manpower cost only. You should think about that what cost will be lost by the organization if a equipment is going breakdown when the unit is in operating condition. So if you realize that cost, then you should do a quality maintenance on the equipment, and you will not compensate the non-OEM parts or the unskilled manpower. All these things you will not compensate it. So, and as I told this one, for the rotating equipment machineries, the spare parts management is a critical thing. Because this rotating equipment is machineries, spare parts, you cannot get it in the local market unless otherwise some common items like the bearings, beepers and all these things. But whenever the OEM parts is concerned, you will be getting these parts from the OEM only. So you should anticipate it, and you should have a sufficient inventory management for those items, because those items are having very high lead time. In my experience, I have seen some rotary machineries are out of service for 6 months, just lying for spare parts worth some $1,000 and you know that the losses will be per day, it will be some $500,000. So the spare parts management is a critical activity for the rotating equipment. Also, as I told before, don't hesitate to call experts when you are experiencing a problem which you cannot able to solve it. There is nothing wrong in that, and we should accept that there is a problem which calls for expert. That's very simple. And finally, I will tell that this rotating machinery is like a human. It's like a man. So, if a failure happens, you have to use the Thiruvallur's way of approach, which is நோய் நாடி நோய் முதல் நாடி அது தணிக்கும் வாய் நாடி வாய்ப்பு செயல். அதாவது அவர் என்ன சொல்றாருன்னா, நோய் என்னன்னு ஆராயணும், நோயின் காரணம் ஆராய்ந்து அதை கணிக்கும் வழியையும் ஆராய்ந்து உடலுக்கு பொருந்தும்படியாக செய்ய வேண்டும் அப்படின்னு சொல்றாரு. அதே தான் இங்கேயும் மெயின்டெனன்ஸை பொறுத்த வரைக்குமே நீங்க ஃபால்ட் என்னன்னு ஃபர்ஸ்ட் பார்க்கணும், அந்த ஃபால்ட்டுக்கு உண்டான ரீசன் என்னன்னு சொல்லிட்டு அனலைஸ் பண்ணணும், அதை எப்படி அந்த ஃபால்ட் திரும்ப வராம இருக்கிறதுக்கு என்ன பண்ணணுன்றதை பார்க்கணும். இதை பார்த்துட்டு அதை நீங்க பண்ணீங்கன்னா திருப்பி அந்த ஃபால்ட் பாத்தீங்கன்னா அதுல அவ்வளவு சீக்கிரத்துல ஏற்படாது அப்படின்னு சொல்றாரு. With this one, I will just conclude my thing. And thank you very much, G.Raja, for your time. And thank you, TEF, for giving me this opportunity.
Thank you, sir. ஆக்சுவலாக இங்கடா திருக்குறள் இன்னும் வரலையே அப்படின்னு பார்த்தேன் நான். ஸோ ஆஸ் யூஷுவல் நீங்கள் திருக்குறளை போட்டீங்க. I think it will be very interesting for the people who are watching this program and very helpful also. I sincerely appreciate our guest speaker Raja Ganapathy coming and sharing with us his insight technical knowledge. Now I would like to invite Kapil for handovering the memento to our guest speaker, Engineer Raja Ganapathy.
On behalf of TEF 2025, I am honored to present this memento as a token of our appreciation, valuable insights and contribution to the today podcast. Thank you, sir.
Thank you, thank you very much.
I would like to sincerely thank our TEF members who are all actively participating and supporting in the technical sessions. Also, I would like to thank TEF 2025 committee for broadcasting such a wonderful events like a podcast for their initiatives as well. Also, thanks for inviting me as well. Thank you so much.
Thank you, G.Raja. Your questions are also very innovative and very interesting. And these questions only brings me a lot of things from me. Thank you very much.
Thank you, sir. Thank you.